consistency, clean and safe sample preparation for metals digestion. So we'll keep this webinar as informative and as light-free as possible. We really want this to work towards how to improve the quality of results in the lab and overall sort of general processes. So a little bit about myself and also the other host today, David. So as Joe said, my name is Nasima Galloway and I'm category manager for EMEA. So that's Europe, Middle East and Africa, and I'm looking after specifically the environmental products. So our Environmental Express range and also the Zephon range of products. So currently I work very closely with David. I have a very strong commercial focus for this particular role. So I work very closely with the labs, the high throughput labs, the research labs, anyone that's doing any type of environmental application and really helping them to achieve the best results possible with the resources that we do have. So I'll pass you over to David and he's going to introduce himself.
Thanks, Nasima. So I'm David. I am here in the U.S. In Charleston, South Carolina, and I'm primarily with the Environmental Express team. I'm on the technical support team, and probably a lot of you who have attended potentially the Environmental Express webinars are familiar with my voice, possibly my picture. You've maybe seen some there. Those who haven't seen it, glad you're on. Welcome. And yeah, we're gonna have a good time, talk about a lot of good nitty-gritty technical stuff, and get everybody informed on some fun things that they can do.
Brilliant, thanks David. And then just a little bit of a collective about who we are. So all in all, myself and David have about 23 years of environmental experience. And that's from my end. I've worked a lot directly with customers. David has been based in the lab for many years, so he's very sort of hands-on with the metal digestion products and really understands how it works from the whole sort of workflow. We both have degrees in myself biochemistry and David's a chemist, so we understand the basics and the concepts sort of behind the work and the theories. And altogether, we have a very strong global outreach of local support. So we work very closely with our teams and other offices in Europe, in the US. We have multiple sites, and we make sure that all of our teams are always fully trained and up to date, and are able to achieve the best form of sort of customer service for their particular countries and entities. And then I'll bring this sort of part here with the sort of Cole-Parmer environmental. It's just another little introduction, so I won't spend too much time here and we'll get into the nitty-gritty of the webinar, but I thought I'd give you all a very quick update of where the company is at the moment, Cole-Parmer, and our sort of very strong environmental focus. So currently, when I say Cole-Parmer environmental, what do I mean by that? It's predominantly a lot of the brands that Cole-Parmer have acquired over the years, which makes a very strong anchor within the company, which means that we're able now to offer a huge range of products, really depending on the type of sampling that you're doing, the type of analysis you're doing. All of our products are geared towards workflows, so we have a great understanding of everything from receiving the sample to analysing the sample, and then I'll show you very briefly of sort of visually how this looks at the moment. So Environmental Express was acquired by Cole-Parmer to begin with around sort of 2016. So Environmental Express is predominantly or will be the range of products that we're talking about today for this metal digestion webinar. And then second to that, we acquired Zephon International that are based in Ocala, Florida. It's a lovely place. I actually was lucky enough to go there this year. And they manufacture their own sample equipment and media for air monitoring and air testing. And again, Zephon, really sits in the sort of occupational hygiene market, which is quite a niche and exciting market here. So we're really excited to have that, as part of one of our brands. And then lastly, HPS, which stands for High Purity Standards. We brought HPS into the Cole-Parmer family in around, it was February sort of this year, so that's fairly new. And HPS manufacture high purity standards, certified reference materials, so all the standards that are required for sort of calibration purposes and analytical purposes for your ICPs and your ICP-MSs. So all in all, these products as a whole create a great strong focus for everything that we can sort of offer you guys, our customers. So we'll go into the webinar today, and what are you going to take home from this? What are you guys going to learn today? Hopefully some really key objectives. Some of you might already do metal digestion and really focused on how to optimize this. Some of you guys may not be doing metal digestion and are purely kind of keen and learning a little bit more about this and how you can sort of benefit from this webinar. So we're sort of focusing on this step here of the main words here are how to improve your throughput and efficient controls with monitoring solutions. Secondly, how to reduce contamination and obtain clean and precise results. So when it comes to metal digestion, I know it's a step in the laboratory procedure which tends to be the most laborious. There are lots of potential points for contamination and that kind of thing. It requires a lot of the analyst's time. I'll bring you in here, David, because I know you've had a lot of experience with metal digestion and really understand the pain points of it.
Yeah, and really not even just the metal digestion, but it's pretty common for a lot of environmental labs, but even with metals, those tend to be some very high volume samples. The digestion process is long. It takes a while. The methods talk about hours worth of digestion, and being able to really optimize the number of samples that you're getting through, getting everything done in a timely manner. Because those people have their own customers that they have to appease as far as getting data to them. So being able to get all that digestion. Again, optimize, get that throughput through, and not only that, but get it done right. There's garbage data is obviously worthless, and so the people need to be able to have confidence that what they're getting is going to be the right answer. So getting it fast and getting it right. Those are really the big sticking points that people work with.
Brilliant. Thanks a lot, David. It was quite nice to sort of look at the visual aspects of some of the points with the workflow to really understand how it works and sort of where we come into and where we're able to help. So very briefly, so the workflow here works first of all with the sample collection step. And that's always the first step within there. The sample collection itself can be, there's a huge variety of sample types that we can, digest and extract metals from. When we're talking land samples, we've got soils, landfill, concrete, various debris and rocks. Water samples is a huge one, and that can be split into drinking water, surface water, groundwater, wastewater. So an endless type, sample type there. And also there's quite some niche applications out there for when it comes to looking at plastics and various products like that. So, plastics in children's toys, that can be quite a popular method sometimes for measuring level of toxicity and that kind of thing. So we always sort of look to, really broaden the range of samples that we're able to work with and make sure customers can fully understand really that we're not just talking waters, but it's a huge sample range. So sample goes into the laboratory, of course, and then depending on whether you're an analyst or you work in the wet chemistry lab or the sample receipt part, there's quite a simple sample preparation step that goes on where your sample will just be placed in a digestion cup, and it's either placed in various concentrated acids or deionized water. Then it goes from the sample prep step into your sample digestion step. So the purpose of this webinar is purely sort of this section here. So we're really going to zoom in on this sample digestion phase and really look at how best to optimize this, because, as David said, it is a very long and laborious step, and usually steps which are really long and require, multiple steps, it generally means there's a lot of margin for errors and that kind of thing. So that's really what we're going to be looking at. And then from the sample digestion phase, we normally have a sample filtration step. So we want to take what's been digested, and simply just remove the debris and the particulates and that kind of thing. So you've got your very, clear sample, a liquid sample, which is then appropriate to be analysed by, generally speaking, an ICP-MS or an ICP-OES. So that's the general workflow that we're talking about here, and we're going to really zoom in on this digestion step. So very quickly, why we test metals. I'm sure a lot of you already know a lot about this, but if you're sort of quite new to this arena, then not quite sure why it's such a popular type of test in the world as it is. Metals themselves, if they are ingested at a certain level, they can become very toxic. In particular for sort of young children, for they're associated with very long-term health benefits in adults. There's also a lot of ecological impacts that could imbalance nature. It can really imbalance the ecosystem for fish and aquatic life, that kind of thing. Metal testing is also very common in agriculture for crops and seeds and that kind of thing. So anything which can really be ingested by humans in the long term and is part of a a food chain or something like that is really the focal point of this. So it's a very important test, is the summary of this. And because it's so important, it is a very regulated test. So unfortunately, you can't just go about putting a method together yourself. Generally speaking, methods are regulated by the various environment agencies or something like that that you're a part of, and that's something that we sort of come on to really about the regulatory bodies behind metal testing. And it's not just metal testing, of course, but a lot of these regulatory bodies, whether you're in the UK and you sort of work under the guidelines of the Environmental Agency, or if you're part of the European Union and you have the European Environment Agency, which would normally offer some various guidelines and that kind of thing of the types of things we should be testing, the what's sort of safe, what's not safe. So these are really, and I'm speaking from my side of the world, what we would tend to deem as appropriate tests, and they would really set the guidelines for that. But how does it work over in the US, David? Sort of with EPA, are they sort of relatively strict with their testing criteria, or do you tend to find that various states tend to do different things?
Yeah, so, and pardon my background noise, the hazards of the working from home, as my neighbors have decided to do a lot of yard work just right now. But yeah, the EPA is, it's a government agency, and they actually, write their regulations and test methods into law. And so that's a lot of the environmental testing labs, or all of the environmental testing labs, those that are generating certified data, they are following specific guidelines that the EPA has put out. And there's a little bit of flexibility in the methods as far as, some ratios, how much samples that you're using, little bit of modifications that you can do. But generally, one lab is going to be doing the same as another lab. It's going to be doing the same as a third lab. And it's going to be a very, very similar process. But then again, the whole metal digestion process is honestly pretty similar. You're heating, you're adding some kind of oxidizing agents, acids, peroxides, whatever, and your goal is to solubilize the analytes of interest. So a lot of these, pretty much, no matter where you are and what method you're following, they're going to be very similar. We're going to be able to talk the same language, as it were.
Brilliant. No, that's really interesting, and that does mirror quite a lot with what I hear from customers and that kind of thing. I think globally, a lot of these methods do mirror each other. I do hear quite a lot that a lot of the methods in in Europe are derivated from the EPA, but we would tend to sort of tweak various aspects here and there. A lot of the time we follow the ISO method for testing. I know I have various customers in the Middle East that tend to follow the EPA, so it really depends on sort of, I guess, where you're based, but overall, I know the goal is exactly the same. And then, it sort of comes into the accreditations and things for this particular type of testing. So a lot of the laboratories and the customers that we work with will have to work to sort of very high standards for this type of test. Coming from the UK, a lot of our customers that do this type of metal digestion would usually be UCAS accredited. Over in Germany, you'd have the sort of DAX accreditation, in Italy, Acredia, France, the COFRAC, and they all sit under the ILAC, so the International Laboratory Accreditation Cooperation, which just really, recognises that this level of testing is something that needs to be performed in a, an ISO accredited laboratory. That's done to, that's been, well, with results that are going to be, very well optimized and that kind of thing. So when it comes to, working to the great sort of government standards, that's usually where a lot of our customers sit for this test. But, we do recognise also that with the ISO method, a lot of the time they do often revise methods and they revalidate methods, and things always change with technology. So this is really where we like to sort of come in and offer that type of assistance and help. So if you are somebody that's looking at revalidating a method or improving a particular method, you want to increase your, or lower your detection limits, you want to reduce contamination, you want to save your analyst time, you want to increase your throughput, increase the profitability of your laboratory, that's where, we are able to help and offer the, individual personalised assistance with that, and, really just do a lot of the work for you and can, really look at optimising that method. So then we'll kick off really with the first pain point, as we might call it. So the metal digestion step there can be a very sort of tricky one. One of the key words here is throughput. So we're now going to look at how you can optimize throughput without sacrificing consistency of results. And what do we mean with consistency? So basically we want batch to batch conformity. We want to make sure that all the samples that are run together are going to be treated in the exact same way. So that's what we mean by consistency. Usually when we look at the throughput, the consistency, the accuracy, which we'll come to later, there's usually one aspect of this that can be compromised if you're working in a quite a high throughput environment, or if there's one aspect there which can be difficult to maintain. So this is where we'd like to make sure that we can offer suitable methods and that level of support where we will be able to make sure that you can tick all 4 of those boxes. So I'll pass you over to David, who's going to discuss a little bit about some of the products that are really optimized for this field. Over to you, David.
All right. So the first thing that, and this is actually something that Environmental Express is kind of built upon, that we're going to talk about here is our hot block. One of the founders of the company, he had that same kind of problem of wanting to be able to do lots and lots of samples together, but keep them all the same. If you've got traditionally, you'll have lots of different hot plates or some of those mesh heating mantles, even lined up on tables and stuff, and even if you can set them all the same and get kind of targeted temperatures, it's less efficient. They're all going to be just a little bit different from one another, and just the overall footprint that you're taking up, the more pieces that you involve in something, the less efficient you are both in your space and your utilization of energy and everything that you're working with. And so the hot block, the idea there is that you've got one centralized location, very compact, where you can do, and what we're looking at here is a 54-well configuration. Those wells hold cups that are designed for a 50 milliliter sample for digestion, and you can do all of those at one time, and we've got a pretty compact footprint. I'll give the U.S. measurements. It's about 1.5 foot, 2 feet long, maybe another 1.5 foot deep or so. And so you've got a really good compact area that you're working in. And then the construction of the block itself, it's metals free. We're looking at a graphite block. Obviously, no metals there. And then the casing is a high-temperature plastic so that it can handle those temperatures that we're going to be using. And so we're getting everything together at one time. We're able to minimize the amount of space we're using, and we're able to maximize the amount of samples that we can do at one time. And again, because this is all done on one digestion apparatus, we've got a very consistent, very uniform digestion environment. Let's go ahead and actually, so on the next slide, on the next couple of slides, we've got some data that we've kind of compiled over the years. This first one here, we're looking at the uniformity of the temperature across that block. And we've just scattered cups through some of the different wells and taken that temperature. And so after our 2-hour digestion period here, we can see that all of our samples are at a very similar temperature endpoint. And then on the next slide, we did a little bit of data compilation here. We've got an average of right around 95 degrees, which was what we were targeting, with a plus or minus of about 0.77. So again, really, really tight numbers that we're working with. And then on the next one, so some methods call for a time-based digestion. Some methods call for a volume-based digestion, where you're going to look to digest down to a certain amount. And so we did some studies on that as well. And then here, our target was 25 milliliters for our final volume. And once again, you can see we've got a very, very tight window of what our samples are doing. We've got a final sample volume of 25.5 milliliters plus or minus 1 and a little bit. And so what that's doing is you can have the confidence that all of the similar samples that you're running, which ideally you're doing batch-wise, you're doing same samples in batches, you can utilize that time-based digestion for some of your volume-based procedures, and be confident that all of your samples will go at the same rate and be doing the same thing. So that's kind of the overall uniformity of the equipment that we're working with. And now, as far as actually doing the prep work, one of the probably most time-consuming parts of getting any of your batches set up, ready to digest, aside from pouring up your sample, there's no real great way to automate that. That's still something that you, as an analyst, have to take some responsibility for. But the repetitive nature of adding your digestion reagents to your sample, whether you're pipetting with a repeat pipetter or a manual pipetter or a bottle top dispenser, however it is you're adding those reagents in, every time you are going from one sample to the next, back and forth from reagent bottle to sample container to pouring some out to pipetting, all of those individual steps are a possible source of contamination and potential errors that you can do, whether you're over or underfilling a little bit from one to the next, possibly with your bottle top pumps. Maybe your hand slip, you don't pull it all the way up, or you don't get it all the way down. Somebody comes to talk to you, you lose place of where you are in adding things. Lots of ways where things can potentially get a little bit messed up. So what we've got here is the auto-block filling station, the auto-block fill. And its design is that you take your existing hot block and place it there in the tray. It can work with all the different sizes that we offer. And then it will fill your digestion reagents in, all your different acids or whatever it is that you're working with. And it can be very precise and consistent for you from sample to sample, so that you know that all your samples are being handled correctly. That's kind of the second stage of automation, as it were, that we add. And then if you really need to have very tight control, or you just need the extra time that's allowed, we have what we call the AutoBlock Plus. This is the 4th generation of this fully automated digestion system that we offer. And what this one can do, not only does it do all of the reagent addition but it can actually control the temperature on the block if you have various ramping stages that you need to go through. It can move the temperature up. It has elevators to raise the samples up and down out of the block if there are any cooling stages that need to happen. And it's even got a very handy final filter volume where you can specify at the end what final volume you wish your samples reconstituted back to. In addition to that, there are some methods that specifically require the samples not to go dry during the digestion procedure. Usually they want to get down to small volumes of your digestion, 5 or 10 milliliters or something, but they say do not let the sample go dry. And so this can actually sense if the sample has gone dry and it will not fill, so that it can mark anything where the digestion was potentially compromised. And so we've got a lot of different ways to kind of help with that digestion process and to make it just a little bit easier depending on what your needs are in the lab and what you're working with.
Brilliant, thanks for that, David. That's really clear and interesting to see, the 3 different solutions we have. If somebody's looking at that and thinking, I'm not sure if I need the autoblock fill or an autoblock plus, it really sort of sits them in the 3 different categories of whether it's that increased throughput you're after, whether you're looking for basic standard level of automation, or if it's sort of a small samples that you are doing and that kind of thing, then the hot block sort of sits perfectly within that. Brilliant. So I'll lead us on to the second part of this. So we've covered the throughput and how we can really assist with that type of element of the that particular step of the workflow. So then we'll come on to the key word here of contamination, which I'm sure if any of you worked in a lab and you've experienced the pains of having your long samples that you've been working on for so long contaminated, and having to restart the whole process again. This will hopefully kind of eliminate that from happening with the metal digestion step, as it can take to a few number of hours usually to finish a particular method. So we'll look at how to minimize your contamination and improve accuracy. So essentially by minimizing, preventing contamination, will improve your accuracy of your trace analysis report. So contamination, when we sort of look at contamination in a laboratory, in particular with metal digestion, the key word here, it is very easy to contaminate your samples that you're digesting. If your end result is going to be ICP, MS or OES, the detection levels of these particular instruments are, really high. Some of the, these instruments, modern day instruments, can detect down to the sort of the parts per billion and also the parts per trillion. And just to give you a visual aspect of what that looks like, it's like dropping a grain of sand in an Olympic swimming bath. So essentially that will just give you a very easy representation of how easy it is to contaminate samples. And I'll just go through a few guidelines before we talk about our our solutions here, but there is a general level of housekeeping that can definitely be improved on, or just some things that you should be aware of from your day-to-day processes, maybe some things you do and you can look back and think maybe we can do that. So if we take care of the housekeeping first and make sure that that's all in check, and then look at really how to optimize and minimize the contamination, David will sort of talk about that later. So a few things that you can do. So just generally working in a clean laboratory, a clean environment, you're cleaning your testing supplies. So the little things like wiping down your hot block before, after and before you've done different batches, just to wipe away any contamination, cleaning the lab bench, cleaning your various attire and accessories. Metal is present in anything, so things like hand lotion, jewelry, the lint from your clothes, all of this contains very low metals of very low levels of metals, sorry, and that can be contaminated in your sample and brought up in an ICP. So it's things like, wearing gloves as well, which we would generally advise when it comes to this type of analysis. So covering these, these basic things first, and just being a little bit aware can definitely help first before we look at the products that we have available. So when it comes to gloves, there are a lot of benefits of gloves. And we can call it PPE, as it's a very popular word in this day and age, but it's all about protecting yourself as well. So a lot of the acids are very corrosive. Depending on some methods can specify very harsh acids. So protecting your hands is always a key element in this. And also we want to protect your samples from any particular contamination and that kind of thing. So we do recommend gloves. However, we always recommend that gloves are just rinsed beforehand with some deionized water, because this can really optimize and reduce any contamination and that kind of thing that's brought up if it comes into contact with your samples. And in fact, David has some pretty cool data here that he's just going to run through about the contamination of gloves and the effect that just doing something as simple as washing them has.
Yeah, we did a big project several years ago looking to kind of optimize some of the products that we make and how we can get them better, suited to the end user's needs. And one of the things that we were examining was, the actual handling of the product. And we found that, as you mentioned, gloves can be a significant source of contamination. We've got, comparison of two of them here. Those powder-free blue nitrile gloves, a lot of people use them. They're very popular in the labs. There's nothing wrong with them. They're great gloves. But just to give you an idea of what they can potentially contribute during your analysis, we digested a sample of the gloves and got those results that you see there in the first column. And those are some pretty large numbers. And so we tested them again, having been rinsed with DI water prior to analysis, and that made a big difference. So then we thought, well, if we're getting that kind of numbers from those common gloves, is there anything that we can suggest maybe to increase the detection limits, or I guess decrease the detection limits, minimize the potential contamination that you get in there? And we did find some fun vinyl gloves, which were pretty good coming right out of the box. Sodium a little bit higher, but all the rest were pretty low. But even then, further increased performance or better performance after rinsing those with DI water. So there's all sorts of different things. I guess basically what we're showing here is there's a lot of different ways, things that you may not even think about, that can potentially contribute to what you're working with. And then more along those lines, so look, the equipment, the consumables, the products that you're using, those are obviously going to be the things that you really have to pay attention to. The digestion vessel, what your sample is in while it digests, is going to be the main source of what you have to look out for, because that's going to be the longest and largest contact time that your sample is going to have. So what we've got is what we call our ultimate cup. And that ultimate cup it's a plastic vessel. Plastics are naturally going to be have very low background concentrations of metals in them, because they are organic products. We've got petroleum-based products here. Glassware, on the other hand, even though glass is not a metal, most labs are using laboratory-grade borosilicate glass. Boron and silicon, they're right there on your metal, non-metal line on your periodic table. And even in the making of borosilicate glass, there are trace elements of other metals that are involved. So you just have to be aware of the container that you're using and look to get the best that you can as far as the analyte signatures for you. Additionally, lots of methods call for some kind of a reflux procedure on your digestion vessels. And again, that's typically been a watch glass that that's on top of your vessel. Again, more potential contamination. You are releasing your acid fumes. They're contacting that glass, and potentially you can get some trace contamination coming out of that glass. So again, following that same design, polypropylene, plastic, watch glasses, and reflux caps. These are designed to fit right there on top of those cups and provide that same reflux action. The reflux cap that you see on the bottom there, the hole in the middle, those are intended for use on the automated stations, so that probe can dispense the reagents through the hole in the middle, and it will still provide the same measure of reflux provided by that the watch glass. I mentioned that these are polypropylene, so polypropylene is important for a couple of reasons. One is to be aware of the temperature restrictions on it. Polypropylene will start to soften around 130 degrees, which generally speaking is going to be sufficient. Most of our digestive methods don't even look for over a boiling temperature, so we're working with sub-boiling temperature ranges. But also, not only are we aware of the melting point and not exceeding that in our digestion process, but when you're done with it, the idea behind this is that with plastic, you don't have to worry about washing it to reuse it, so you can eliminate the potential carryover between samples. That then leads to some concerns about waste and what do we do with it all. With polypropylene, it's all completely recycled, and so it can go right back into the recycling program. So with keeping your samples contained, self-contained, a lot of times at the end of your digestion process, you want to have some kind of filtration where there can be some insoluble material left over in your sample. We want to make sure to keep our ICPs, whatever instruments you're using there, we want to keep them free of particulates. Particulates are going to wreck those tiny tubing lines faster than anything else. And so there's a couple different options for sample filtration. The first one we've got is what we call our FilterMate. It works a lot like our French coffee press. So you've got a filter and a housing that goes directly down in the cup. And then there you can see the what we call the pusher. That's just another polypropylene piece. So you can push that filter directly down through the sample, and it will trap all your particulates down at the bottom and allow your filtered liquid to come on top. And this is great because you can then, you can just put the cap right back on it and store it just like it is with the filter still in there. It's again, minimizing the transferring steps, the potential sources of outside contamination that can happen with your sample. Occasionally, you may need to do a vacuum filtration so that you can get a complete recovery of your digested liquid. In that case, we've got what we call our FlipMate, which, as you see here, it's a double cup configuration. You start with your digested sample in one cup, and you screw a filter housing on top of it, and it has another screw thread on the other side where you would then attach an empty cup. And I'm doing hand gestures, even though none of you can see me, to show you how to screw things together. And then it will attach directly to a vacuum pump, or we've got this manifold here that will handle multiple samples at a time, up to 12 there. And so, again, slight transfer from one cup to another, but again, these cups are going to be clean to begin with, and so you can minimize the potential carryover from one to another. And finally, we've got, for those really special projects where you need to have some very, very low digestion levels, we have what we call our Ultimate Clean Cup. So the Ultimate Cup and the Ultimate Clean Cup, they both actually come with a certificate of analysis. We do our own analysis on the cups and do some digestions before that batch is approved and sent out, and we verify that it meets some minimum detection limits of what we have on our cups. And our standard Ultimate Cup has very good detection limits and generally are suitable for most customers' needs. But we have had people who say, I need just a little bit better, or oftentimes the Ultimate Cup is in the range we need, but sometimes we need to guarantee that's a little bit lower. You know, there may be some variation in that non-detect area that we have. And so as part of that study that I was referencing earlier, we looked for ways to make an even better product. And we came up with the ultimate clean cup. We discovered that one of the main sources of contamination came in getting the product to the customer. And so the process that we came up with was a capping and packaging solution directly off the mold. The standard Ultimate Cup comes bulk packaged. They're in a bag, but the cups are all dumped in together. And you open your box, open the bag up, and you can pull individual cups out. This one comes, as you see here, sealed up in a tray. There's 25 cups in that tray, and it allows you to essentially do one full batch of samples. We're figuring about 20 samples plus a few extra for your quality control samples. And then that one individual tray is used all at one time. And it comes with several pair, one pair for each tray, 5 trays in a box. So you get 5 pairs of those vinyl gloves that we were talking about earlier. We figured if we found these cool gloves, let's give people the best opportunity that they can for using these cups. So those are all lots of different ways that we've got that can, again, help the varying needs that you may have in addressing that background contamination level, minimizing it, keeping it as low as possible so that you can feel good about the data that you're generating for your internal or external data users.
Brilliant. Thanks for that, David. That was really interesting, sort of seeing that all visually and understanding, you know, in each step exactly where the contamination can come from. And that brings the actual webinar to a close. I think we'll just jump in straight away. And if any of you have been sending questions over to Joe, who's been working in the background, sort of compiling all of your questions, myself and David will be happy to answer them now.
Yeah, thanks, Nas. There have been quite a lot of questions, actually, I'm pleased to say. So I'm going to read them out in order of appearance. So the first one came in is, how has the ILAC standards affected the current lab methodology since its inception? Not sure who's best placed to answer that one.
So with the ILAC, how have the ILAC standards affected the current methodology?
Yeah, how has the ILAC standards affected the current lab methodology? Yeah.
Yeah, so with the ILAC standards and the methodologies surrounding metal digestion, the principle of metal digestion always remains the same. But what we do see with, you know, changes of standards and that kind of thing, it tends to be they're now asking for very specific, you know, digestion cups, very low, you know, leaching. You know, they kind of sometimes offer various tweaks of heating profiles and that kind of thing. It really depends on the types of metals that you're wanting to extract most of the time, as various metals will extract at different temperatures. Some metals require stirring capabilities. So it depends really on you know, what it is you're looking to sort of extract as well. But generally it's the vessel that you're using and the heat that they'd mainly sort of tweak.
Okay, that's brilliant. Thanks, Nas. In regards to the filling station, can you add different volumes to different vials?
That's a good question. So no, you cannot. In order to kind of keep, we expected that there would be some digestion going on as well on the block. The idea is that you can set that temperature for your digestion to happen. And so we kind of limited it to be basically everything on the block is going to be the same method, which would mean it's all going to have the same reagents and the same volume of reagent to each one. Now, I guess technically you could set up different methods on the software, where you would select one method for a certain group of samples, and it would run through all of them, and then you can select another method then after it's completed for another group of samples. It gets a little bit awkward to do that. So the easy answer is no, but you may be able to finagle your way around it if you're really dedicated.
Okay, that's a great answer. Thanks, David. There was actually a question I missed by accident. Apologies to the person that asked. Is HPS ISO 17034 certified?
Yes, it is. They carry the ISO 9001, 17025, and 17034 accreditations.
Brilliant. Okay, that's great to know. The next question I've got here is perhaps more of a clarification than a question. They went on to say, did you say that the watch glasses and the reflux caps can be washed and reused? You said the reflux caps work the same way as the watch glasses. I think that's more of a clarification statement from yourself.
Yeah, the idea, again, is that they are not to be reused. The whole thought behind doing the plastic consumable pieces is that you use them one time, you've done with your sample's been disposed of, you've now got these empty used containers, and then those get recycled, disposed of appropriately according to your lab procedures, so that there is zero chance of cross-contamination from one sample to another.
Okay, that's great. Thank you. There is one question that I can answer actually, which is yes, this is being recorded, and we will certainly send a link to this recording once the webinar's over. So give it a couple of days, and we'll be sending this out to you. So I just thought I'd clarify that. A couple of people have asked. Moving on, do the Ultimate Clean cups come in 15 milliliter size?
No, they do not. That Ultimate Clean Cup only comes in the 50 milliliter size. We had to make some decisions as far as it does require its own special setup, and the demand just wasn't quite there for that 15 milliliter size. So right now it is only in the 50 milliliter size that we make that product.
Okay. Right, this question's coming with a couple of typos, so I'm going to try my best with this one. Why is microwave digestion not considered? With the new CEM, i.e., you can have program running safer, and it's safer than open hot block. So I think the main question is, why is a microwave digestion not considered?
Yep. Microwave is a good, valid digestion procedure, and it is a good option for a certain group of people. What I've experienced and in discussing with lots of different customers and working with them is that it's kind of honestly a middle ground for what people are looking for. Hot blocks are excellent for the smaller labs who don't have the budget for a microwave. It allows them to do a good number of samples at a time and work through them, and it's not that big of an upfront cost. There is a middle ground where the microwave makes sense for some people, and it's mostly going to be a comparison. You've got to look at kind of your budget flow of where the microwave fits as far as its startup cost versus how many samples you can get through. Microwaves are actually pretty fast. On an individual sample basis, a microwave is faster than the digestion block, than the hot block. But then once you start scaling up past, I think the biggest microwave that I've seen is a 24 samples. There might be a 36 one. Once you start needing to run, and I know labs that need to do this, need to run 100, 200 samples in a day, the number getting a couple of hot blocks, 3-4 hot blocks can easily allow you to do that all at one time. And that it just, the cost and the scale just kind of start to overtake what the microwave can do. So, and then honestly, we don't have a microwave that we offer, so I don't have any direct solutions that I can support and offer for a microwave.
Okay, it's no problem. That's a great answer. What do you suggest drying your gloves with after rinsing with DI water?
Air dry.
That's a good question.
You're going to want to stay away from your communal rags. An air dry should work. Single, the paper towels can be good, but you have to worry about the lint. So get the lint-free stuff.
It would make sense to pre-wash them and then, line them up, contain them in a quite a safe, sterile area, and then, make sure you wear them without touching the outsides of them, before using them.
Okay, great. I've got a really interesting question. It's quite long. I'll try and make this as simple as I can. So there's somebody who is using performing metals digestion using the EPA 3050B method. And he says that the method calls for a 2-hour digestion in nitric and 2-hour in peroxide. I'm not sure how it was validated here, but those times have been cut to 30 minutes, and I am observing a low bias in general. And he goes on to say, to complete the question, any comments on the approximately 25% digestion period when dealing with typical soils and reference soil standards? So it's a bit of a long one.
Yeah.
I can reread it if you want.
Yep, I see that there. So I'm not sure. Again, that's a really good question about that. Cutting those times down to 30 minutes, especially for soils. I just do not think that most of your soil digestion can get the amount, can get a full digestion. I can't remember whether 3050B is intended to be in available metals or a total metals digestion off the top of my head. But I think that 30 minutes is probably short. And I'm sure someone was, attempting to make some due dates for a customer, or hold times or something. I don't know, probably not hold times. That'll kind of long hold time. But I feel like you could probably try to get back closer to the method specified digestion times. I know that when we do the adaptations in our manual for all the different EPA methods and such that we have, all we've really done is scale the size. Most of the methods start off calling for 100 milliliters. Well, we do have that 100 milliliter cup, but 50 is the more popular one. And so we've just kind of scaled the size of the sample and the volume of the read down to fit that cup. And we've kept all the digestion times the same when we reference them in our manual. So that's probably where you need to start is looking at that digestion time.
Okay, great stuff. Just to remind everyone, we will create a Q&A doc, which will get sent around at a later date, not too long after this finishes, and we'll make sure that answers included as well. David, do you have acid or solvent permeation data on the vinyl gloves?
Not with me. I'm sure we can get that from the manufacturer supplier. I'll have to look for that information.
Okay, no problem. There was actually quite a few glove related questions. There's another one here. If you rinse your gloves with deionized water, forgive me, how do you dry them without contaminating them? I guess that's a similar answer to before, right? The air dry.
Yeah. Yep.
Okay. Okay, we'll move on then. Is there any suggestions with samples with residual solvents, such as oil extractions from hemp plants?
Oh, that's a good one. So that gets into the chemical compatibility with the digestion cups. You'll have to make sure to check your solvent that you are using and see what its compatibility is with polypropylene. Some solvents are okay, some solvents not okay. So that's a totally different chemistry there that we would have to investigate. In those instances, that actually may be where the glass containers are better. And we do offer glass containers for the hot blocks. I didn't even get into this earlier. We do have two different temperature ranges on our hot blocks. The basic one goes up to 150 degrees, and then we have a model called our hot block 200, which I believe was what we had in the image there, which goes up to 200 degrees. And since we're intending for those to go higher than the temperature of our plastic vessels, we do offer containers that are applicable to those temperature ranges. So when we start moving over into some of our organic extractions, some of those glass vessels may actually be a better fit for those. We don't have a lot of data on how to do those. That's a relatively new field, especially they're talking about working with hemp now. At least it's a relatively new legal field. And so that's something that we would definitely be interested in working with people on gathering data and developing procedures and kind of working with you to make a good setup for that kind of thing.
Okay, that's great. It's a good answer. Thank you, David. I think we've got time for one more question, and I'm not sure who can answer this one, so I'll just ask it. It's regarding the filling station. So, what type of pump does the Environmental Express ABF 5000 need? I think it goes on to say the pump is included in the instrument or should be put. Okay, is the pump included in the instrument or should it be purchased separately?
Oh, yeah, so it actually uses I'm drawing a blank on the brand name, the Masterflex tubing pump. It's built in on the instrument, and it's all included. You don't have to, buying that one unit will get you everything. Well, the hot block is separate, but the auto block fill unit comes with everything that's needed to run it.
So predominantly, we also manufacture that pump and pump head. As Masterflex is also one of our brands, so we've got very, obviously tight controls on how it's manufactured and supply and that kind of thing. So that's always an advantage to that.
Okay, there is one last minute question that's dropped in, and we've got a minute left, so I'm going to ask it if that's okay. Someone's saying they're using micropipetters to add acid and to make the reagent water. We need to use 25 ml, etc. HN03 or HCl to make it use plastic or glass volumetric pipettes. Does that make any sense? I'm not sure if I've got that as a question.
It does. It makes a little bit of sense. Yep. So it really depends on the level that you need to reach and how good you are with your repeated actions. I would almost always prefer to use a repeat pipetter with the plastic tips because they are more consistent when operated properly. Using the bulb or even the drawing up pumps on the top of the glass volumetric pipettes, it can lead, there's a lot more room for error. Now, if you personally are very consistent, then I believe that the glass pipettes can, on an individual basis, be more accurate. But on a consistency basis, most of the time for our metals digestions, the amount of acid down to the microliter isn't quite as important for the overall digestion process. So the accuracy, or rather the consistency and accuracy of the repeat pipetter will be good enough to get your acids in, and it will, I believe, help to minimize the contamination better. It also gives you more opportunity to do a little bit of pre-treatment if you need to on the pipette tips. There are ways to, rinse those or something if you need to. So that was kind of a long-winded, I guess, not really very committal answer, but
it's a good answer, and it's taken us nicely into the last section. So just before I hand back to Nas, I just want to thank everyone for turning up today, and just to let you all know that there is a very short survey that we really would appreciate you filling out, which I think will be on your screens any moment now. And Nas is just going to quickly show us the key contact details should you have any further questions based on your region. Nas, I think there's a contact slide.
Brilliant, thanks, Joe. And just to mirror what Joe said, really appreciate your time, and the questions have been amazing and really encouraging. It sounds like a lot of you guys have had some really good thoughts and ideas surrounding your own application. I've just put some email addresses here for the main offices, so whether you're based in the US, in the APAC region, in EMEA, and you'll contact there the sort of your main hub essentially. But what I will say is, in the thank you email that we're going to send you, we will include your local distributor. So if you're in the UK, if you're in France, Italy, Turkey, or Israel, we've sort of clearly identified there who our key partners are that we've been working with for sort of many years in those particular countries, and they will be your sort of point of contact essentially. But if anything's unclear, then please do contact any of the Cole-Parmer emails present. And we will be happy to help. But thank you very much for today. It's been a pleasure hosting this. Brilliant. Yeah, we'll send the email out today, but all I could say now is have a lovely rest of the day, and thanks again.